Okay, so your test is next class period. You need to make sure that you do the review. It looks just like your test. Of course, it's different numbers or different statements, okay? We're going to try to go through this quickly because I don't have a whole lot of time. So first, looking at patterns, for this one, very similar to the test, we see that every other number is counting by 1. So like 12, 13, 14, this needs to be 15. And then we have 9, 10, 11, this should be 12. Okay. Here, it looks like I have to multiply. So like 1 times 3 is 3. 3 times 3 is 9. 3 times 9 is 27. So to get here, I would do 27 times 243, and that gives me 6,561. And then if I multiply these two together, I get 1,594,323. Okay, so for this one we have square, circle, triangle. So square, circle, triangle, and then back to square. Okay. Now for this part, I didn't make you do the symbols like P implies Q, but it might help you jot them down, like where we have to flip them. And then remember that conditional and inverse go together, where you just do the not. And then converse and contrapositive go together, so not Q, then not P. Okay, so to save time, I'm going to put this up on the screen in just a second for you to pause and fill this in or check your work with mine. We're going to go ahead to number 3. So number 3, they want to know, are these good definitions, yes or no? So if I write point that lies on the same line are collinear. If I think about the converse of that, if I have a line that has collinear points, they're made up of points that are lie on the same line. That seems reasonable, yes. That makes sense to me. Okay, a compass is a geometric tool. A geometric tool is a compass. No, even though that is true, there's also rulers, protractors, other types of geometric tools. So no, because geometric tools could be just more than a compass. Okay, so for this part up here in the middle, I would like for you to do and then pause, do it, and then check with mine. So here is what I had. So you might want to pause and then come back to this, but I'm going to explain. So once I wrote these out, I decided, are they true or false? And I came up with true. So if everything is true, then we know biconditional means that these had to be true. And if these could be true, you were able to write this statement with if and only if in it. Okay? I tried to put the blue parts that were important in here. And then because these were all true, there was no need for a counterexample, so I just put NA for not applicable. And you get 1 point for putting that because it shows like you understand that these are true, so you don't need a counterexample. Okay? So I'll leave this like this so you can pause and jot down. All right, so I'm going to go ahead and go to the next video.